Welcome back to our electronics laboratory. In this session, we will perform experiment number 2, the breadboard experimenter. The objective of this experiment is to prepare the breadboard for experiments. This setup will be equipped with the data input and output, LED indicators, and positive and negative 5 volts power sources. The materials needed are a 5 volts power supply, solid wires, 8 LEDs, 8 1K ohms resistor, and a breadboard. Always remember to observe safety precautions. Disconnect the power source before constructing any circuit. First, mount your breadboard into a sturdy base such as wood or plastic. This prevents unwanted movement during the experiments. This is the breadboard, used to build circuits without soldering. It has 3 main parts. First, the terminal strips, the middle area where you place components. Each vertical column of 5 holes is connected. Second is the power rails, the long rows on the top and bottom. The red line is usually positive, the blue or black ground. They're connected horizontally. The last part is the center divider. The gap in the middle separates 2 sides. It's where IC chips go so their pins don't connect. Insert the LEDs into the breadboard, connecting their negative legs to the ground rail of the power rail. Attach a 1K ohm resistor in series with each LED to limit current flow. Next, use the solid wires to connect the top and bottom grids for power distribution. Red wires are for positive supply, while black wires are for ground. Now, connect the input jumper wires to the resistors. Setting wire to the ground represent logic 0, while connecting it to the positive rail represent logic 1, or it means it have a power. And that's it. Connect your 5 volts power supply when the input wires are set. The LED should light up. This confirms that the breadboard experimenter is ready for future digital logic experiments. Now, let's take a breadboard experimenter to the next level by adding an integrated circuit, the 74LSO8. This IC contains 4 independent AND gates, each with 2 inputs and 1 output. we connected blue-red LEDs to pin 1 and 2 of the 74LSO8. These LEDs represent the inputs. Right now, both blue LEDs are on, meaning both inputs are high. The green LED is connected to pin 3, which is the output of the gate. Since both inputs are high, the output is also high. That's why the green LED is on. This confirms the truth table and the AND gate. The output is only true when both inputs are true. This simple LED demonstration makes digital logic easy to see and understand.